All right, so I'm gonna focus on radical expressions today, like simplifying square roots, and maybe talk about how it works when we do cube roots, and from there you can figure out fourth and fifth roots, things like that. So we're simplifying radical expressions. All right, so everything is gonna start with this list of perfect squares, right? 1 times 1 all the way up to maybe 15 times 15. You should know those, have those in your heads. See that? 149, 16, 25, 36, 49, 64, 81, 121, 144, 169, 196, 225. Like when you see those numbers, when you hear those numbers, even if you don't have to use or take square roots, you should automatically recognize, like, okay, those are special numbers. These are perfect squares. Now, anything after 16 to the second power, you just work on memorizing those, but you should understand the pattern as you start going up by tens, though, like 20 to the second, 30 to the second, 40 to the second, 50 to the second. Like, you should understand those patterns, 400, 900, 1600, 2500, because they're extremely similar to what we got right over in here anyway. 400, 900, 1600, 2500. You see the patterns? So that right there can help you locate or at least get into the ballpark of what your perfect squares might land. All right, so if I had to simplify the square root of 24, it all comes from my factors. Remember, we're simplifying something that sits under a radical symbol. So we don't want any set of factors. We want the one that would include the largest perfect square possible. And if I look up and down this list of factors, that will be the one that I need to use, because none of these are perfect squares. One is a perfect square, but that doesn't help me break my numbers down and make them any smaller. So that brings me to here. I break this up into square root of 4 times the square root of 6, with that one being my perfect square. So now that is a regular old 2 now. 2 square root 6. And now we're looking at something that's simplified, 2 square root 6. And remember, it comes from finding the factor that has the largest perfect square within it. And then you can get to here. So that one's just a numerical expression. We just took a square root of 24. We found the perfect square times another number and simplified it. Now, there's a way that we can apply this with numbers, and there's a way we can apply this with variables. So I'm going to get to the reason why this works or how it works, and so that you can apply it to either numbers or variables. All right, so there it is. I have the square root of 24 x squared y to the 4th. This is one that we have to simplify, so let's talk about how this works. Notice how everything switched up so that you can see what all the exponents are saying. So now I have a 2 to the second power times a 6. I have an x to the second power. Then I also have a y to the second power to the second power. All right, so there's a quote that I ran by doing some research on a Black history figure, one of my heroes, where she simply said, radical simply means grasping things by the root. Now, she was speaking in terms of freedom fighting, but I'm a math teacher, and I was like, oh man, there's a relationship there. So like when I look at that, or once I heard that, it kind of made sense. So that's why I wanted to talk about what's actually going on behind the scenes and how it works. So I'm going to go back to the board so that you can see exactly what we mean by grasping things by the root. So this symbol here is what we call a square root, right? So if we're grasping things by the root, we're grasping things that are being squared, all right? So in other words, this 2 is being squared. That means 2 is the root, all right? X is being squared. X is the root. And then y to the second power is being squared. So y squared is a root. So basically, when we grasp things by the root under this root symbol, the ones that I circled are the ones that you can sit over here now, because we know what the roots are. That's a 2x y squared. Those are the ones that you can sit over here. The ones that I did not circle, are the ones that stay under, and that happens to be the 6. So we grasp these by the root. Everything else stays under the square root symbol. So back to my list. So when you see these numbers, it's showing you the relationship here. You square root this, that's the square root. That's the root. The square root of 9 is 3. The square root of 16 is 4. So everything that's being raised to the second power would be considered the root when we're taking a square root. And I hope that makes sense. So it's good to know these lists of numbers, because once we graduate past square roots, we can talk about cube roots. So I'm going to just look at one more example using the cube root, and then that's how it applies if you go up to your higher powers. So here's another radical expression that needs to be simplified. We have a cube root of 27x to the third y to the 6th. So we're not dealing with a square root anymore. We're dealing with a cube root. The wisest thing to do at this point is, anytime you're dealing with a certain type of root, is to have your own list of numbers that match with the root that you're dealing with. So in other words, when we were taking square roots, we had a list of squares. Now that we have a cube root, we should have a list of cubes. So I'm going to show you a list of cubes. You don't have to make an extremely large list. It just depends on what needs to happen, how far into that list you may have to go. So here's my list of cubes right here. I have 1 to the third all the way up to 10 to the third. And if I need to grab any more, I just make my list a little longer. But normally, if I can stay within here, that's enough for me to kind of figure out what's going on. So here's my list of cubes, and here's my numbers here. So this is how we're going to look at it. So that's the first thing I'm going to do. I know I need to rewrite. 27 should ring out, because 27 comes off of this list, and that's 3 to the third power. So I have a 3 to the third power. I have an x to the third power. Now this one, you got to pay real close attention. Remember, we're dealing with something that's a third power. So that means technically I have y squared in there 3 times. Get what I'm saying? Because everything that I'm trying to do is I'm trying to find all my roots for my 3's now. So see how I have all my third power showing? So that means 3 comes out, x comes out, y to the second comes out. So to simplify this expression, what I'm left with is a 3xy squared. I grasped everything by their roots. All right, so here we go. 128 is the same thing as saying 64 times 2. And remember, 64 comes straight off of this list. So 4 to the third power. So basically 64 times 2 is 128. This one right here, I have x to the 5th power. So I definitely do have x to the third, but I still have 2 more left. So these 2 combined is x to the 5th power. Same thing with y to the 4th. I know I have a y to the third inside of there with an extra y left over. So y to the third times y, this total gives me y to the 4th. The reason why we have to do this is because 3 is the exponent that we have to find embedded into this whole problem. If there's a third power in there anywhere, we have to be able to find it. So 4 to the third is where we found our first cube. X to the third is where we found our other one, and y to the third is where we found our other one. Now remember, all of these have cubes inside of them somewhere. The whole thing with simplifying is we have to understand how these numbers can be embedded into a problem where you don't see them, and we have to basically deconstruct these numbers to show them again. So you kind of expose them and you pull them out. You get what I mean? So the ones that I circled are all the ones that are raised to the third power. And the reason why I circled the third power is because I'm dealing with a cube root. So 4x, y, those come out. I grasp those by the roots, sit them here. Everything that was not circled goes right back under here. This has been simplified using cube roots now. All right, so whenever you go on YouTube, you can find me here. You can do a search, that's the correct spelling. It'll populate a list similar to what you see here. This is the picture you look for. This is my channel you subscribe to. I do one video each day I come to work over all sorts of things, anything from elementary to advanced placement calculus, not including statistics. I still haven't gotten into my statistics yet. This is how you find me. There's your correct spelling. There's the picture. Like and subscribe, share. Just trying to help people out.